Long before our time, Earth was not the world we know today. It was a place of giants, of hunters and survivors, where oceans hid monsters and skies carried wings larger than our imaginations. Their bones whisper across the ages, but their full stories remain unfinished, fragments of mysteries lost in time. Join us as we uncover these forgotten worlds. And before we begin, remember to like, share, and subscribe, because your support helps us continue this journey into the unknown. In the comments, tell us where you're watching from and which mystery you'd like us to explore next. So, let's journey back through time, into the lost worlds where giants once ruled. Tyrannosaurus rex in the annals of prehistoric life. Few names carry as much weight as Tyrannosaurus rex. The very sound of it conjures images of a towering predator, ruling the late Cretaceous landscape with unmatched ferocity. But beyond the familiar silhouette of powerful jaws and massive legs lies a creature whose story is far more complex than popular culture suggests. Tyrannosaurus rex lived approximately 68 to 66 million years ago in what is now North America. At nearly 40 feet in length and weighing up to 9 tons, it stood as one of the largest land predators ever to walk the earth. Its skull, armed with serrated teeth the size of bananas, was engineered for crushing bone. Yet the skeleton reveals more than strength. It shows balance, adaptation, and the subtle artistry of evolution. The massive tail acted as a counterweight, allowing this giant to move with surprising agility. For decades, scientists debated the true nature of T. rex. Was it an unstoppable hunter, chasing down prey with terrifying speed? Or was it a scavenger, feeding on carcasses left behind by other creatures? Evidence has painted a more nuanced picture. Bite marks found on the bones of Triceratops and Edmontosaurus show signs of healing, proof that these animals survived attacks long enough for wounds to mend. This suggests that T. rex actively hunted, though it likely scavenged when opportunity arose. In nature, the line between predator and scavenger is rarely absolute. Its senses also reveal a predator's design. The eye sockets face forward, granting depth perception essential for tracking prey. Inside the skull, cavities for the olfactory bulbs were exceptionally large, indicating a powerful sense of smell. Combined with strong hearing, T. rex was not merely a brute force. It was a highly tuned organism, capable of perceiving its world with acute precision. Yet, mysteries remain. Fossil evidence hints at possible social behavior, with trackways suggesting that more than one individual may have moved together. Were they solitary giants, or did they sometimes roam in loose groups? The fossil record offers clues but no final answer. And then there is the greatest mystery of all, extinction. Just as T. rex reached its evolutionary peak, the Cretaceous world collapsed under the weight of a cataclysm. Whether by asteroid impact, volcanic upheaval, or a chain reaction of climate change, the king of dinosaurs vanished along with nearly all of its kind. Today, each discovery, every fossil unearthed, every trace preserved, adds another layer to the story of Tyrannosaurus rex. But like the giant itself, the full truth remains just out of reach, waiting in the stone for us to uncover. Velociraptor in the shifting sands of prehistory, one name has become synonymous with cunning and speed: Velociraptor. Popular culture has cast it as a swift, intelligent predator, leaping onto its prey with lethal precision. But beyond the image shaped by cinema lies a creature both smaller and stranger, whose true story is still being pieced together from the fossil record. Velociraptor lived approximately 75 million years ago, during the late Cretaceous period, in what is now Mongolia and parts of Central Asia. Unlike the towering giants that shared its world, Velociraptor was modest in size, barely 2 meters long and weighing no more than a modern-day turkey. Yet its build was unmistakably designed for predation. Long legs suggest speed, a stiffened tail provided balance, and the most iconic feature, a sickle-shaped claw on each hind foot, hinted at a deadly hunting strategy. The claw, measuring over 6 centimeters, could be raised and locked in position, ready to slash or pin down prey. Some paleontologists believe it was used not to disembowel, but to grip and hold victims, much like modern birds of prey do with their talons. This interpretation bridges an even greater mystery: the evolutionary link between dinosaurs and birds. Velociraptor fossils reveal cool knobs on the forearm bones, evidence of feathers. These were not for flight, but perhaps for insulation, display, or even balance during the hunt. The skull tells another story. Long and narrow, with recurved teeth ideal for slicing flesh, it suggests an animal built for efficiency rather than brute strength. And its brain case reveals enlarged olfactory regions, meaning a keen sense of smell likely guided its pursuit. Together with binocular vision, Velociraptor emerges as a predator tuned to precision, relying on agility and perception rather than sheer size. One fossil discovery, frozen in time, captures the drama of its life. Known as the fighting dinosaurs, it preserves a velociraptor locked in combat with a protoceratops. The predator's claw is embedded in its opponent's neck, while the herbivore bites down on its arm. Both creatures perish together, perhaps under a sudden sandstorm, leaving behind a moment suspended for 75 million years. Yet questions remain. Did velociraptors hunt alone or in coordinated groups? Did feathers play a role in communication, or were they remnants of a distant lineage on the path to flight? The answers lie scattered in stone, waiting for careful hands to uncover. Velociraptor may have been small in stature, but its legacy looms large. An agile predator that not only shaped its ecosystem, but also continues to blur the line between reptile and bird, past and present Spinosaurus in the long lineage of predatory dinosaurs. One stands apart from all others, Spinosaurus. Towering even above Tyrannosaurus rex in length, it was unlike any creature of its age. With its elongated snout, conical teeth, and massive sail rising from its back, Spinosaurus challenges our very picture of what a predator could be. Its mystery lies not only in its size, but in the unusual adaptations that suggest it may have been the first truly semi-aquatic dinosaur. Spinosaurus lived around 100 to 95 million years ago, during the Cretaceous period, in what is now North Africa. Fossils suggest it reached lengths of up to 50 feet, making it the largest known carnivorous dinosaur. Its skull, shaped more like a crocodile's than a traditional theropod's, was filled with teeth perfectly designed for gripping slippery prey. This hints at a life spent near rivers and deltas, hunting massive fish that thrived in the warm waters of ancient Sahara. The creature's most striking feature was its sail, formed by elongated spines on its back. Some reached over 6 feet tall, creating a structure whose function is still debated. Did it regulate body temperature, display dominance, or perhaps store energy in fat reserves like a camel's hump? Each fossil discovery deepens the debate, leaving paleontologists to speculate on a structure without parallel in today's world. Its limbs reveal further secrets. The forearms were unusually strong, equipped with curved claws that may have helped capture prey or pull the animal through shallow water. The hind limbs, once thought powerful enough for running on land, are now seen as shorter and more paddle-like. Combined with a long, flexible tail, Spinosaurus appears increasingly adapted to swimming, an apex predator bridging two worlds, land and water. Yet, the fossil record remains frustratingly incomplete. Much of what we know is built from fragments discovered across decades, sometimes lost to war or erosion. Early reconstructions portrayed Spinosaurus as a land-based giant, striding like a taller cousin of T. rex. Only in recent years, with new discoveries in Morocco, has the picture shifted toward a water-dwelling hunter. This constant revision makes Spinosaurus one of the most enigmatic creatures in paleontology. Even today, questions linger. Did Spinosaurus ambush prey from the riverbanks, or fully submerge like a crocodile? Was the sail a signal, a weapon of intimidation, or something more subtle that we have yet to imagine? What is certain is this. In the primeval wetlands of North Africa, Spinosaurus reigned supreme, an ancient riddle carved into stone, still waiting for its final pieces to be found. Triceratops in the fading days of the Cretaceous period, when giants still roamed the earth, one creature stood as both defender and survivor, Triceratops. With its massive frill, 3 formidable horns, and bulk that rivaled an elephant, it has become one of the most iconic dinosaurs ever discovered. Yet, behind this familiar image lies a story full of unanswered questions about its life, its battles, and its final moments before extinction. Triceratops lived around 68 to 66 million years ago in what is now North America, sharing its world with predators like Tyrannosaurus rex, measuring nearly 30 feet long and weighing close to 10 tons. It was among the largest of the horned dinosaurs, or ceratopsids. Its anatomy speaks of both strength and adaptation. A bony frill stretching from the skull, and 2 long brow horns with a smaller one at the nose. These features likely served multiple purposes: defense against predators, displays during mating rituals, and perhaps even recognition among members of its herd. The frill itself is one of Triceratops' greatest mysteries. Some paleontologists argue it functioned as a shield, protecting its neck from attacks. Others suggest it was a canvas of display, brightly colored in life, used to attract mates or establish dominance. Fossil evidence shows vascular grooves in the bone, hinting that skin stretched across the frill may have carried patterns or hues unseen in the fossil record. Its diet paints a vivid picture of its role in the ecosystem. With a beak suited for clipping tough vegetation and rows of shearing teeth for grinding, Triceratops likely fed on cycads, palms, and ferns that thrived in its environment. Its powerful jaws suggest it could process large quantities of fibrous plants, shaping the very landscapes it lived in. The relationship between Triceratops and Tyrannosaurus rex adds another layer of intrigue. Fossilized bones of Triceratops show bite marks from T. rex teeth, some healed, suggesting they survived attacks. Others bear evidence of feeding long after death. Whether these encounters were battles between predator and prey or scavenger and carcass, they reveal a complex dynamic between 2 of the most iconic dinosaurs of the Cretaceous. And still, questions remain. Was Triceratops a solitary grazer or part of herds that moved across ancient floodplains? Did its horns evolve more for combat or communication? With each discovery, paleontologists gain pieces of the puzzle, yet the full image remains incomplete. As the Cretaceous period ended in cataclysm, Triceratops vanished along with its kin. Today, its fossils stand as monuments to a world on the edge of extinction. Giants locked in mystery, their secrets buried in stone, waiting to be uncovered. Stegosaurus in the tapestry of the Jurassic world. Few creatures are as instantly recognizable as Stegosaurus. With its double row of towering plates and spiked tail, it looks as though it walked out of a prehistoric legend. Yet beneath this unusual armor lies one of paleontology's most enduring mysteries. How did this strange, plant-eating dinosaur live, and what role did its remarkable features truly play? Stegosaurus roamed North America about 155 to 150 million years ago, during the late Jurassic period. Growing up to 30 feet long but with a small, low-slung body, it was a herbivore adapted to feeding on ferns, cycads, and other low-lying plants. Its skull was tiny compared to its massive body, housing a brain no larger than a walnut. This striking imbalance has long fascinated scientists, raising questions about how such a large animal functioned with such limited brain power. The most iconic feature of Stegosaurus is its plates, large, kite-shaped bones arranged in 2 rows along its back. Some reached over 2 feet tall, and their purpose has been widely debated. Early theories suggested they acted purely as armor, but their placement does not align with efficient defense. More recent studies point to a different function. The plates were richly supplied with blood vessels, hinting they could have been used for thermoregulation, helping the animal absorb or release heat. Others suggest they may have been for display, brightly colored in life, perhaps used to attract mates or signal dominance. At the other end of its body lay the thagomizer, the 4 sharp spikes on its tail. These were not merely ornamental. Fossil evidence shows damage to the bones of predators that match the puncture wounds these spikes could inflict. Stegosaurus may have been slow and low to the ground, but it was far from defenseless. One well-aimed swing of its muscular tail could deter even the largest Jurassic carnivores. Still, mysteries remain. Did different species of Stegosaurus arrange their plates in unique ways? were the plates flexible, shifting as the animal grew? And perhaps most intriguingly, how did such a large creature thrive with such a small brain? Some paleontologists suggest its nervous system was more distributed, with specialized nerve centers near the hips controlling the powerful tail. Stegosaurus has often been called a dinosaur built by committee, with features so unusual they seem almost mismatched. Yet these adaptations allowed it to survive for millions of years in a world dominated by giants. Even today, its plates and spikes whisper secrets from a deep past, leaving us to wonder how much more remains hidden in the stone. Brachiosaurus in the primeval landscapes of the Jurassic, a giant stretched its long neck toward the treetops, towering above nearly all other creatures of its time. This was Brachiosaurus, one of the most iconic sauropods, whose unusual proportions and immense size made it a living monument of its age. Yet, despite its fame, the mysteries surrounding how this colossal herbivore lived and thrived continue to challenge our understanding of the past. Brachiosaurus lived around 154 to 150 million years ago in what is now North America. At over 80 feet in length and weighing as much as 60 tons, it was among the largest land animals ever to exist. Unlike many of its sauropod relatives, Brachiosaurus had distinctive proportions. Its forelimbs were longer than its hind limbs, giving it a giraffe-like stance. This elevated posture lifted its body high off the ground and allowed its neck to reach vegetation nearly 40 feet above the forest floor, levels untouched by most other herbivores. Its skull, small in comparison to its immense body, was fitted with spoon-shaped teeth, perfect for stripping leaves from conifers, cycads, and ginkgos. Paleontologists believe Brachiosaurus could consume hundreds of pounds of plant matter daily, fueling a massive digestive system that acted as a living engine. Yet the mechanics of how such an animal managed to circulate blood to its elevated head remain a puzzle. Theories suggest it must have had an extraordinarily powerful heart, capable of generating immense pressure to push blood up its long neck. Still, whether such a system could truly sustain the creature remains a point of debate. Fossil evidence also raises questions about its lifestyle. Did Brachiosaurus live in herds, moving together like modern elephants? Or was it more solitary, wandering the Jurassic floodplains alone? Trackways hint at group behavior among sauropods, but direct evidence for Brachiosaurus remains elusive. Its immense size may have offered protection from predators, yet juvenile individuals would have been vulnerable, relying on the cover of adults or the safety of herds. For years, depictions showed Brachiosaurus wading in lakes to support its weight, but new studies reveal its body was well adapted to land. Its skeleton was lightweight for its size, filled with air sacs similar to those in modern birds. These not only reduced weight but may have supported efficient respiration, helping sustain such a massive frame. Still, mysteries linger. How did Brachiosaurus interact with its environment? Did it shape forests by feeding, much like elephants do today? And how did such a giant reproduce and raise its young in a world filled with predators? Brachiosaurus remains a symbol of grandeur from a vanished world, its towering silhouette a reminder of life's power to push boundaries, and of secrets still hidden within the stone. Argentinosaurus in the quiet plains of prehistoric South America, a giant once walked whose very presence redefined the limits of life on land. Argentinosaurus, named for the country where its remains were found, stands as one of the largest dinosaurs ever discovered, a creature so vast that its true scale is still difficult to comprehend. And yet, despite its fame, what we know about this colossal herbivore is drawn from fragments, leaving much of its story veiled in mystery. Argentinosaurus lived about 94 to 97 million years ago, during the late Cretaceous period. Estimates suggest it stretched over 100 feet in length and may have weighed as much as 70 to 90 tons. To put that into perspective, it was longer than 4 school buses lined end to end and heavier than a dozen African elephants combined. Its massive frame places it among the titanosaurs, a group of sauropods that pushed the boundaries of size in ways no land animal has since achieved. But the puzzle of Argentinosaurus is that it is known only from partial fossils, vertebrae, ribs, and fragments of limb bones discovered in Patagonia during the 1980s. From these few remains, paleontologists have reconstructed its immense proportions. Yet, without a complete skeleton, much remains uncertain. How exactly did its limbs support such staggering weight? How fast could it move across the floodplains it called home? And what role did it play in shaping the ecosystem around it? Its lifestyle can only be inferred through comparisons. Like other sauropods, Argentinosaurus likely fed on the tallest vegetation, conifers and broadleafed plants that grew in the warm Cretaceous climate. To sustain its bulk, it would have needed to consume hundreds of pounds of plant matter each day. Its long neck allowed it to sweep through treetops, while a whip-like tail stretched behind for balance. Some scientists speculate it may have traveled in herds, both for protection and to exploit vast areas of vegetation. But with its sheer size, it may have had few natural predators once fully grown. Still, questions linger. Did its heart and lungs operate like those of modern birds, with air sacs lightening its bones and providing efficient breathing? Could its circulatory system sustain blood flow to a body so large? And perhaps most fascinating of all, was Argentinosaurus truly the largest dinosaur to ever live? Or do even bigger giants remain buried in the rock, waiting to be unearthed? Argentinosaurus reminds us of life's ability to stretch to unimaginable extremes. Yet its incomplete story leaves us with a haunting sense of scale and mystery, as if the land itself once trembled under giants whose secrets still lie hidden beneath the earth. Giganotosaurus in the warm plains of prehistoric South America, a predator rivaling Tyrannosaurus rex once stalked its prey. This was Giganotosaurus, a name that means giant southern lizard. At nearly 43 feet long, it was among the largest carnivorous dinosaurs to ever walk the earth. Yet, despite its fearsome size, Giganotosaurus remains a creature wrapped in mystery. Its behavior, hunting strategies, and true power still pieced together from scattered fossils. Giganotosaurus lived around 98 million years ago, during the mid-Cretaceous period, in what is now Argentina. It belonged to the Carcharodontosaurids, a family of predators with long, narrow skulls and blade-like teeth. Unlike the deep, bone-crushing jaws of Tyrannosaurus, Giganotosaurus had a lighter, elongated skull designed for slicing through flesh. Its teeth, sharp and serrated like steak knives, suggest it may have relied on repeated slashing bites to weaken prey rather than crushing them in a single attack. Its body proportions tell another story. Though massive, Giganotosaurus was built for speed compared to some of its gigantic relatives. Long, muscular legs suggest it could move quickly across the floodplains, perhaps reaching speeds of up to 30 kilometers per hour. This agility would have been useful against the enormous herbivores of its time, including Argentinosaurus, giants that dwarfed even Giganotosaurus itself. How exactly a predator confronted such behemoths remains debated. Did it hunt in coordinated groups, harassing and wearing down prey, or did it rely on ambush tactics, striking vulnerable individuals? The fossil record offers only fragments of answers. The first remains were discovered in Patagonia in the 1990s, including a skull over 5 feet long. Since then, additional bones have helped fill in the picture, but much of the skeleton remains unknown. Without complete evidence, reconstructions of its exact size and appearance vary, fueling ongoing debates among paleontologists. Its role in the ecosystem adds yet another layer of intrigue. Giganotosaurus lived in a world dominated by massive sauropods and armored dinosaurs, creatures that required specialized strategies to overcome. Bite marks on fossils hint at predation, but whether it regularly hunted or scavenged remains unresolved. What is certain is that it occupied the role of apex predator, shaping the balance of life in its environment. And still, mysteries endure. Was Giganotosaurus truly larger than Tyrannosaurus rex? Or do fragmentary fossils exaggerate its size? Did it roam in packs like wolves? Or was it a solitary hunter? Each discovery raises new questions, reminding us how much remains hidden in stone. Even now, the shadow of Giganotosaurus stretches across prehistory, not just as a predator, but as a puzzle, challenging us to uncover how giants once ruled the earth. Quetzalcoatlus high above the rivers and plains of the late Cretaceous, shadows once stretched across the land, shadows cast not by dinosaurs, but by wings wider than a small aircraft. This was Quetzalcoatlus, one of the largest flying creatures to ever exist, a pterosaur whose size and anatomy continue to astonish scientists and challenge our understanding of flight itself. Quetzalcoatlus lived around 70 million years ago in what is now North America. With an estimated wingspan of up to 36 feet, it rivaled the span of a modern glider. Standing on the ground, it may have reached the height of a giraffe, supported by long, pillar-like forelimbs. Unlike birds, its wings were formed from membranes of skin stretched across an elongated fourth finger, giving it a structure both alien and efficient. Yet, despite its immense size, the question remains, how exactly did it take to the air? Its lightweight bones held the key. Hollow, yet strong, they reduced body mass while maintaining stability. Some paleontologists suggest Quetzalcoatlus launched itself skyward with a powerful leap, using all four limbs to vault into flight before sweeping its wings in great arcs. Others argue it may have relied on thermal updrafts, soaring like a vulture over open landscapes. The mechanics of such flight, with a body perhaps weighing 200 kilograms or more, remain a subject of ongoing debate. On the ground, Quetzalcoatlus was no less formidable. Its long, stiff neck and toothless, spear-like beak suggest it was a predator or opportunistic feeder. It may have stalked smaller animals, snapping up prey in quick strikes, or scavenged carcasses left behind by larger dinosaurs. Fossil evidence, however, leaves much unresolved. Was it primarily a hunter of terrestrial prey, or a master of aerial fishing, gliding over waterways in search of life below the surface? Its very name, drawn from the feathered serpent god Quetzalcoatl of Mesoamerican mythology, reflects the awe it inspires. Discovered in Texas in the 1970s, its fossils reshaped our picture of pterosaurs. No longer seen as fragile or secondary to dinosaurs, Quetzalcoatlus proved that these flying reptiles reached extremes of size and adaptation unmatched in Earth's history. And yet, the mysteries remain vast. Did it travel in flocks, filling the skies with sweeping wings, or was it a solitary wanderer of ancient horizons? Could such a giant truly sustain long flights, or did it spend more of its life stalking on land? Quetzalcoatlus stands as both a marvel and an enigma, a ruler of the skies whose silent wings remind us how much of the ancient world remains hidden in unanswered questions. Archaeopteryx in the limestone quarries of southern Germany, a creature was preserved in stone that would forever change our understanding of evolution. Archaeopteryx, often called the first bird, stands at the crossroads of two worlds, part reptile, part avian, and entirely enigmatic. Its delicate fossil remains reveal a mosaic of features that blur the boundary between dinosaurs and modern birds, raising as many questions as they answer. Archaeopteryx lived about 150 million years ago during the late Jurassic period. Roughly the size of a raven, it possessed feathered wings and a long feathered tail, giving it the appearance of a bird. But a closer look tells another story. Its jaws carried small, sharp teeth, and its hands bore claws at the tips of 3 long fingers. Its skeletal structure retained the hallmarks of theropod dinosaurs, the very group that gave rise to giants like Allosaurus and Velociraptor. The feathers of Archaeopteryx are among its most striking features. Preserved in extraordinary detail, they show a complex structure, nearly identical to those of modern birds. This suggests they were capable of aiding in flight. But here lies the puzzle. Was Archaeopteryx truly a flyer, or merely a glider? Its breastbone was not as developed as in modern birds, casting doubt on whether it had the powerful flight muscles needed for sustained flapping. Some paleontologists argue it may have leapt from tree to tree, gliding with bursts of wing beats, while others see it as a ground dweller, taking short flights to escape predators. Its discovery in the 19th century came at a pivotal time. The first fossil, found in 1861, appeared just 2 years after Charles Darwin published On the Origin of Species. For scientists and the public alike, Archaeopteryx seemed a living example of evolutionary transition, a creature caught between reptile and bird. Yet, the story has only grown more complex as new fossils of feathered dinosaurs from China reveal that bird-like features were widespread among theropods. Archaeopteryx may not have been unique, but part of a broader, diverse group experimenting with the mechanics of flight. And still, mysteries remain. Did Archaeopteryx use its wings for hunting insects in the canopy? or for short bursts of powered flight across open ground. Were its feathers primarily for display, thermoregulation, or true aviation? Locked in stone for millions of years, Archaeopteryx continues to whisper secrets of life's great transition. It is more than just a fossil. It is a reminder that evolution rarely moves in straight lines, and that the path from earthbound reptile to soaring bird was filled with strange, half-forgotten experiments. Coelacanth, deep beneath the ocean's surface, where light begins to fade and shadows stretch long, lives a creature thought to have vanished with the dinosaurs. The coelacanth, a fish once believed extinct for over 65 million years, resurfaced in the modern era as a living relic of Earth's distant past. Its reappearance has challenged scientific assumptions and opened a window into evolutionary history, while leaving behind mysteries that endure even today. The coelacanth belongs to a lineage stretching back over 400 million years. Its fossil record seemed to end abruptly at the close of the Cretaceous, leading scientists to believe it had been wiped out in the same extinction event that claimed the dinosaurs. But in 1938, off the coast of South Africa, a fisherman hauled in an unusual catch, one that would astonish the scientific world. It was unmistakably a coelacanth, alive, its strange lobed fins and distinctive body revealing a species thought lost forever. Unlike most fish, the coelacanth possesses paired lobed fins supported by bones resembling the limbs of early land animals. This unique anatomy links it to the very origins of tetrapods, the first vertebrates to step onto land. It is, in a sense, a living cousin to our own evolutionary story, carrying within its body clues to a transition that reshaped life on Earth. The coelacanth's features are as remarkable as its survival. It has a hinged skull that allows its mouth to open extraordinarily wide, and a notochord, a primitive, fluid-filled structure, rather than a fully developed spine. Its scales are thick, armored with a substance called cosmine, found in no other modern fish. Even its blood contains unusual compounds suited to the deep, cold environments it inhabits. Today, coelacanth are found in two distinct regions: the waters off the Comoros Islands near Africa and the seas of Indonesia. Living at depths of up to 700 meters, they spend daylight hours in underwater caves, emerging at night to hunt squid and smaller fish. Yet, their secretive lives mean much remains unknown. How long do they truly live? Decades, perhaps even a century. How do they reproduce in such remote and hidden environments? The survival of the coelacanth is both a marvel and a mystery. It raises questions about how many other so-called extinct species may linger in unexplored corners of our planet. For now, the coelacanth drifts silently in the dark waters, a ghost of prehistory reminding us that the boundaries between past and present are never as final as they seem. Megalodon in the vast blue oceans of Earth's past. An unseen hunter once ruled with unmatched power. Megalodon, the largest shark ever known, swam the seas between 23 and 3.6 million years ago. With a body stretching over 50 feet in length and jaws strong enough to crush a whale's skull, it remains a symbol of primal dominance. Yet, despite its size and legacy, much about this giant remains cloaked in mystery. Megalodon, whose name means giant tooth, is known almost entirely from its massive fossilized teeth and scattered vertebrae. Some of these teeth measure more than 7 inches long, twice the size of those of the great white shark. From these fragments, scientists have reconstructed a predator of extraordinary scale. Its bite force is estimated to have been over 40,000 pounds, making it one of the most powerful bites in Earth's history. The oceans Megalodon inhabited were rich and teeming with life. Fossil evidence suggests it hunted large marine mammals, including early whales, seals, and dolphins. Bite marks on fossilized whale bones reveal a strategy of crippling prey with devastating bites before finishing the kill. Its wide distribution, from North America to Europe, Africa, and Asia, shows that Megalodon was a global predator, capable of dominating ecosystems across warm, shallow seas. And yet, its exact appearance remains uncertain. Unlike bony animals, sharks are made largely of cartilage, which rarely fossilizes. Did Megalodon look like an enlarged great white shark, as once thought? Or was it more closely related to the extinct mako sharks with a sleeker body built for speed? Reconstructions vary, reflecting the limits of the fossil record. The greatest mystery of all is its extinction. Around 3.6 million years ago, Megalodon vanished. Climate shifts cooled the oceans, shrinking its warm water habitats. At the same time, new predators like the ancestors of modern killer whales emerged, possibly competing for food. The decline of large whale populations, a primary food source, may have sealed its fate. Still, the suddenness of its disappearance leaves questions. Did isolated populations linger longer than we think, hidden in unexplored seas? Even now, Megalodon captures the imagination because it embodies both power and absence. A predator so immense, yet gone so completely. Its fossilized teeth, found on beaches and riverbeds, are the only remnants of a creature that once shaped the oceans. And as long as its story remains incomplete, the question lingers in the depths. What other giants of the past still wait, unseen, in the shadowed corners of Earth's oceans? Plesiosaurus beneath the ancient seas of the early Jurassic, a long-necked figure glided silently through the water. With its broad body, for powerful flippers, and serpent-like neck, Plesiosaurus has captured imaginations for nearly 2 centuries, often linked to myths of sea serpents and legendary creatures. This marine reptile remains one of the most iconic symbols of prehistoric oceans. Yet its true way of life is still shrouded in mystery. Plesiosaurus lived around 200 million years ago, when shallow seas covered much of what is now Europe. Reaching lengths of up to 15 feet, it was not the largest of the plesiosaurs, but it was among the earliest and best known. Its anatomy was unlike anything seen in the modern world. A compact, barrel-shaped body provided buoyancy, while 4 strong, paddle-like flippers worked in harmony to propel it through the water. Unlike fish or modern reptiles, its movement has been compared to the underwater flight of penguins or sea turtles, using graceful strokes to glide across the seafloor and open waters. The most striking feature of Plesiosaurus was its neck, which contained more than 35 vertebrae. This gave it an extraordinary range of motion, though exactly how it was used remains debated. Some paleontologists believe the neck allowed it to ambush prey from below, sweeping its head side to side to snatch fish or squid. Others argue the long neck would have created drag, raising questions about whether it truly hunted in open waters or fed in shallower environments where stealth was more effective. Its skull was small, with slender jaws lined with sharp, interlocking teeth designed to grasp slippery prey. Unlike some of its later relatives, Plesiosaurus lacked the massive size to dominate the seas, but it occupied a unique niche, swift, agile, and efficient in its hunting. Fossils suggest it swallowed prey whole, its long neck acting as a flexible conduit from jaws to stomach. Yet many mysteries linger. Could Plesiosaurus raise its head above the water like a swan, as once imagined, or was its neck too heavy and stiff for such movements? Did it live in groups, or was it a solitary predator of the seas? And what role did it play in the broader ecosystem of early Jurassic oceans, where ichthyosaurs, ammonites, and other marine life competed for survival? Plesiosaurus reminds us that the seas have always held forms both familiar and strange, creatures that defy simple comparison to the world we know. And as we uncover more fossils from ancient seabeds, the elegant mystery of its long-necked silhouette continues to invite new questions about life in the deep past. Mosasaurus in the ancient seas of the late Cretaceous, a predator rose to dominance that dwarfed nearly every other marine hunter of its time. This was Mosasaurus, a massive marine reptile whose name means lizard of the Meuse River, where its first fossils were discovered in the 18th century. With its elongated body, paddle-like limbs, and jaws lined with rows of sharp teeth, Mosasaurus embodied the apex of oceanic power. Yet, as formidable as it was, many aspects of its life remain veiled in mystery. Mosasaurus lived about 82 to 66 million years ago, in oceans that stretched across what is now Europe, North America, and Africa. At lengths exceeding 50 feet, it was one of the largest mosasaurs, rivaling even modern whales in scale. Unlike fish or sharks, Mosasaurus belonged to a group of reptiles closely related to monitor lizards and snakes. It was not a dinosaur, but a creature that had returned to the sea after its ancestors once walked on land. This evolutionary reversal gave rise to a streamlined body built for speed and power. The skull reveals much about its hunting strategy. The jaws were hinged to open wide, armed with conical teeth designed to seize and hold slippery prey. Fossil evidence suggests a diet that included fish, squid, turtles, and even other mosasaurs. Some specimens preserve bite marks, hinting at violent struggles and perhaps even cannibalistic encounters. With double-jointed jaws and a flexible skull, Mosasaurus could swallow large prey whole, much like modern snakes. The movement of Mosasaurus through water is still a subject of study. Early depictions imagined it undulating like an eel, but recent evidence points to a powerful tail fin driving it forward, more like a shark. Its four flippers may have been used for steering rather than propulsion, allowing it to maneuver with agility despite its size. Beyond its anatomy, Mosasaurus also leaves questions about its behavior. Did it hunt in packs, overwhelming prey through coordinated strikes? Or was it a solitary predator ruling territories alone? And how did it give birth? On shore like its reptilian ancestors, or in the open ocean as a fully marine creature? Fossilized remains of smaller Mosasaurs suggest the latter, painting a picture of live births in the sea, an adaptation that freed it from land entirely. When the Great Extinction event struck 66 million years ago, Mosasaurus vanished along with the dinosaurs. But its fossils remain, preserved in chalk and limestone, a reminder of the giants that once ruled beneath the waves. And as we study their remains, one question lingers. What other secrets still lie hidden in the depths, waiting to emerge from the stone and reshape our view of prehistory? Kronosaurus in the primeval oceans of the early Cretaceous, a predator named after a titan of Greek mythology reigns supreme, Kronosaurus. With jaws longer than a grown man and teeth the size of bananas, it was a marine reptile whose power and presence echoed the might of the god it was named for. Yet despite its fearsome image, much about this ocean giant remains uncertain, its story pieced together from fragments scattered across ancient seabeds. Kronosaurus lived around 125 to 100 million years ago, its fossils discovered in Australia and parts of South America. It belonged to the pliosaurs, a group of short-necked plesiosaurs adapted for speed and power. Measuring up to 33 feet in length, it had a massive skull that made up nearly a third of its body. Inside were conical teeth locked in a bite capable of crushing through bone and shell, suggesting a diet that included turtles, fish, and other marine reptiles. Its anatomy reveals a hunter built for efficiency. With four strong flippers working in unison, Kronosaurus propelled itself like a living engine, capable of sudden bursts of speed to overtake prey. Its shorter neck distinguished it from the long-necked plesiosaurs, favoring raw bite force over stealthy reach. The fossil record suggests it patrolled shallow seas, where it could ambush unsuspecting prey in violent strikes. The story of Kronosaurus also highlights the challenges of reconstructing prehistoric life. When one of the most complete skeletons was unearthed in Queensland, Australia, in the 1920s, scientists overestimated its length by including too many vertebrae during reconstruction. For decades, textbooks portrayed it as a 40-foot monster before later studies corrected its size to a smaller, yet still formidable range. This serves as a reminder that even giants of the past are subject to human error in their rediscovery. But questions linger. How exactly did Kronosaurus hunt? Did it rely on ambush tactics? Or did it actively chase prey in open waters? Did it rule alone? Or were there multiple top predators sharing the same seas? Its fossil record is limited, leaving paleontologists to speculate on behaviors that can only be imagined from scattered remains. What is certain is that Kronosaurus vanished with many other marine reptiles by the end of the Cretaceous, leaving only bones embedded in stone to speak of its reign. And as each fragment is studied, one wonders, how much of its true nature lies waiting, still hidden beneath layers of earth and ocean, waiting to challenge our understanding of the monsters that ruled the ancient seas? Liopleurodon in the dark seas of the Middle Jurassic, a predator of staggering proportions glided through the waters, its presence inspiring awe and fear alike. This was Liopleurodon, a marine reptile whose reputation as one of the most formidable hunters of its age has grown larger than life. Yet behind the legends, the fossil record reveals a creature both extraordinary and enigmatic, leaving scientists to unravel what was myth and what was reality. Liopleurodon lived about 160 million years ago. Its remains discovered in Europe, particularly in France and England. It belonged to the pliosaurs, a lineage of short-necked plesiosaurs built for speed and power. At an estimated length of 20 to 25 feet, though some early reconstructions exaggerated its size to more than double that, Liopleurodon's body was dominated by a massive skull filled with sharp, conical teeth. These jaws were designed to seize and hold, making quick work of prey that ventured too close. Its anatomy was a study in efficiency, for strong flippers powered it through the water with strength and control, allowing it to maneuver swiftly despite its bulk. Its long, pointed snout gave it a streamlined profile, reducing drag as it cut through ancient seas. With eyes positioned forward, it likely had excellent binocular vision, a vital tool for detecting and tracking prey beneath the waves. Fossil evidence suggests Liopleurodon preyed on fish, cephalopods, and smaller marine reptiles. Its powerful jaws could generate enormous force, and once prey was caught, there was little chance of escape. Unlike long-necked plesiosaurs, which may have relied on stealth, Liopleurodon embodied the role of an ambush predator, striking with explosive bursts of speed. But much of its story remains speculative. Because the fossil record is incomplete, debates continue over its true size and dominance. While some reconstructions cast it as a 50-foot leviathan, most modern estimates suggest it was closer to half that length. Still, even at its more modest dimensions, it was among the apex predators of its environment, rivaled only by other marine reptiles of its time. Liopleurodon's legacy extends beyond science into popular imagination. Its fearsome image has been magnified in documentaries and stories, cementing its place as one of the ocean's most iconic prehistoric hunters. Yet, separating fact from embellishment remains one of paleontology's ongoing challenges. What we know is that Liopleurodon once patrolled the Jurassic seas with unmatched skill. But what remains hidden? Its behavior, its true size, and its place among the giants of its age continues to remind us that even the mightiest predators leave mysteries that time alone cannot fully answer. Dunkleistus, long before dinosaurs ruled the land, the seas of the Devonian period were home to a predator unlike anything alive today. This was Dunkleistus, a massive armored fish whose jaws could snap shut with astonishing force. Living over 360 million years ago, it was one of the earliest vertebrate superpredators, a reminder that oceans have always been arenas of power and survival. And yet, despite its fearsome reputation, much of its life remains cloaked in mystery. Dunkleistus belonged to the placoderms, an ancient group of armored fishes. Unlike modern sharks or bony fish, its head and thorax were encased in thick plates of bone, forming a natural shield against attacks. Measuring up to 30 feet in length, it was one of the largest predators of its era. But perhaps its most striking feature was its mouth. Instead of teeth, Dunkleistus possessed sharp, bony blades that acted like shears, capable of slicing through the toughest armor of its prey. Studies of its jaw mechanics reveal astonishing power. With a bite force estimated at over 8,000 pounds, Dunkleistus ranks among the strongest biters in Earth's history. Its jaws could open and snap shut in a fraction of a second, creating a suction effect that drew prey into its mouth before the bony plates slammed together. Fossil evidence shows it likely fed on armored fish, ammonites, and even members of its own kind, suggesting it was both predator and cannibal. Despite these fearsome traits, Dunkleistus is known from incomplete fossils. Most discoveries preserve only the armored head and thorax, while the rest of its body remains speculative. Reconstructions often show a streamlined, shark-like tail, but no fossil evidence confirms its exact shape. This uncertainty leaves scientists to wonder about how it swam, how fast it could move, and what role it played in shaping marine ecosystems. The environment it inhabited was equally dynamic. Known as the Age of Fishes, the Devonian seas teemed with diversity. Yet, Dunkleistus ruled these waters for millions of years, sitting firmly at the top of the food chain. Its eventual disappearance, along with many other placoderms, is linked to mass extinction events that reshaped life in the oceans. Still, questions remain. How exactly did such a massive fish reproduce? Did it give live birth like some modern sharks, or lay eggs hidden in the depths? And what did the rest of its body truly look like? Dunkleistos may be gone, but its armored skulls, preserved in stone, remind us that the oceans have always harbored giants. And somewhere, in the silence of the fossil record, the unanswered parts of its story still wait to be revealed. Smilodon, saber-toothed cat, in the grasslands and woodlands of the Ice Age, a predator with elongated fangs cast a shadow over its prey. This was Smilodon, often called the saber-toothed cat, an apex hunter whose appearance is as iconic as it is mysterious. With its massive jaws armed with blade-like canines, it embodies the strange and deadly adaptations that evolved during the Pleistocene epoch. Yet, despite thousands of fossil remains, the life of Smilodon is still a puzzle waiting to be solved. Smilodon lived in the Americas between 2.5 million and 10,000 years ago. Unlike modern big cats, it was stockier and more heavily built, with muscular forelimbs and a shorter tail. Measuring up to 7 feet long and weighing as much as 600 pounds, it was designed for power rather than speed. Its most defining feature, the saber-like canines, could grow over 7 inches, far longer and thinner than the teeth of any living predator today. But how were these formidable weapons used? Theories vary. Some scientists suggest Smilodon delivered precise killing bites to the soft throats of prey, avoiding the risk of breaking its fragile teeth on bone. Others propose it may have waited in ambush, pinning victims with its powerful forelimbs before delivering a swift, fatal strike. Fossil evidence of puncture marks on Ice Age herbivores such as bison and ground sloths supports the idea of specialized hunting tactics. Though no consensus has yet been reached, the environment Smilodon inhabited was rich with giant prey. Mammoths, mastodons, camels, and horses roamed the landscapes of the Pleistocene, providing abundant opportunities for a predator of this size. Yet Smilodon itself was not invincible. Injuries found in fossils, broken teeth, and damaged bones suggest that life as a saber-tooth was dangerous, and that these predators may have hunted animals far larger and stronger than themselves. Perhaps most intriguingly, evidence from sites like the La Brea tar pits in California hints at possible social behavior. Fossils of multiple Smilodons found together, including individuals with healed injuries, suggest they may have lived in groups, providing support and care much like modern lions. If true, this would challenge long-held views of solitary big cats and paint a picture of complex social lives. Yet, Smilodon's reign came to an abrupt end. Around 10,000 years ago, it vanished along with much of the Ice Age megafauna. Climate change, dwindling prey, and the arrival of human hunters may all have contributed, but the exact cause of its extinction remains unknown. Smilodon's fossils give us bones, teeth, and tantalizing clues, but the full story of how this saber-toothed predator lived, hunted, and died continues to lie just beyond our reach, hidden in the deep shadows of prehistory. Woolly mammoth Mammothus. Across the frozen steppes of the Ice Age, a colossal figure once moved slowly through the snow, its curved tusks sweeping the air like ancient scythes. This was the woolly mammoth, a creature so iconic that it has become the very symbol of the Pleistocene epoch. Adapted to survive in some of the harshest environments ever faced by large mammals, it thrived for hundreds of thousands of years. And yet, despite its prominence in both fossil records and human history, the full story of its life and disappearance remains unresolved. The woolly mammoth, Mammuthus primigenius, first appeared about 400,000 years ago and spread across the northern hemisphere, from Europe and Asia to North America. Standing up to 11 feet tall at the shoulder and weighing as much as 6 tons, it was similar in size to today's African elephant. Its most distinctive features were its long, spiraling tusks and thick coat of shaggy hair, beneath which lay layers of fat and skin adapted to retain heat in the frigid tundra. Their world was one of extremes. During the last Ice Age, mammoths roamed vast grasslands known as the Mammoth Steppe, a unique ecosystem that supported herds of grazing giants, from bison to woolly rhinoceroses. With high-crowned teeth suited for grinding tough grasses, mammoths played a central role in shaping these landscapes. Their movements, grazing habits, and even their dung helped sustain the balance of life in these frozen plains. For early humans, mammoths were more than distant giants, they were essential to survival. Archaeological sites reveal evidence of mammoth hunts, where entire communities worked together to bring down one of these massive animals. Their bones and tusks were used for tools and shelter, their hides for warmth, and their meat for sustenance. Even in art, mammoths appear etched into cave walls, standing as symbols of reverence and dependence. But around 10,000 years ago, most populations of woolly mammoths vanished. Climate change thawed their icy world, shrinking the grasslands that sustained them. At the same time, human hunting pressure may have driven already fragile populations closer to extinction. A few isolated herds lingered on remote Arctic islands, surviving until just 4,000 years ago, contemporary with the building of the Egyptian pyramids. And so, the mystery endures. Were mammoths lost mainly to shifting climates, or did human hunters deliver the final blow? And with advances in genetic research, could fragments of frozen DNA one day allow science to bring them back? The woolly mammoth remains a giant suspended between past and future, its story unfinished, its presence still echoing across the icy silence of prehistory. Mastodon mammoth, in the dense forests of ancient North America, long before humans built cities or tilled the soil, herds of massive, elephant-like creatures once roamed. These were mastodons, members of the genus Mammoth, close relatives of today's elephants, yet distinct in ways that set them apart from their woolly mammoth cousins. With their long tusks and towering forms, mastodons were icons of the Ice Age world, creatures that shaped their ecosystems, inspired early human hunters, and left behind mysteries that endure to this day. Mastodons first appeared more than 25 million years ago and survived until about 10,000 years ago. Unlike the mammoths, which preferred open steppe and tundra environments, mastodons thrived in woodlands and swamps. Standing around 8 to 10 feet tall at the shoulder and weighing up to 6 tons, they were slightly smaller than mammoths but still formidable. Their name, mastodon, comes from the Greek for breast tooth, a reference to their distinctive molars. These teeth, shaped with pointed ridges rather than flat grinding surfaces, reveal a diet dominated by leaves, twigs, and branches rather than grasses. Their appearance carried both familiarity and difference. Like elephants, mastodons had long trunks and tusks, some curving dramatically outward and upward. Yet their bodies were more robust, with shorter legs and straighter backs. Fossil evidence suggests they were adapted to life in heavily forested regions, browsing on shrubs and trees rather than grazing in open plains. Mastodons also played a central role in the story of early humans. Archaeological discoveries show evidence of mastodon hunts, with stone spear points found embedded in their bones. To Ice Age communities, mastodons would have been sources of food, tools, and shelter. But these encounters may also have contributed to their decline. As human populations spread across the Americas, mastodon numbers dwindled. Combined with dramatic climate shifts at the end of the Pleistocene, their fate was sealed. Yet, the details of their extinction remain debated. Did overhunting by humans push them to the brink, or did changing ecosystems remove the forests they depended on? Recent finds of preserved DNA and frozen remains hint at sudden population collapses, but the exact balance of causes remains unclear. Today, mastodon fossils are discovered across North America, from swamps to riverbeds. Their bones a reminder of a world both familiar and alien. They lived alongside mammoths and saber-toothed cats, but carved out a niche uniquely their own. And as science continues to probe their remains, the mastodon story reminds us of the fragility of giants, that even the mightiest creatures can vanish, leaving only questions written in stone and bone. Allosaurus in the floodplains and forests of the late Jurassic, a predator stalked the land long before Tyrannosaurus rex claimed its throne. This was Allosaurus, a carnivore that ruled 150 million years ago, its reign spanning continents and ecosystems filled with giant herbivores. Sleeker and more agile than the massive predators that came later, Allosaurus remains one of the most studied, and yet still mysterious dinosaurs of its age. Allosaurus grew up to 30 feet in length and weighed around 2 tons. Its name, meaning different lizard, comes from the unique shape of its vertebrae compared to other dinosaurs discovered at the time. With long, muscular legs and a tail built for balance, it was built for pursuit as much as for ambush. Unlike the deep, crushing jaws of Tyrannosaurus, Allosaurus possessed lighter skulls equipped with sharp, serrated teeth, perfect for slicing rather than crushing. One of its most striking adaptations was the design of its jaw. Paleontologists believe Allosaurus could open its mouth wider than most predators, possibly up to 80 degrees. This allowed it to deliver swift, slashing bites, tearing into prey and weakening it through repeated attacks. Some theories suggest it may have even used its skull like a hatchet, driving its upper jaw down into flesh with the force of its neck muscles. The prey it hunted tells us much about its world. Allosaurus lived alongside giants such as Diplodocus, Camarasaurus, and the heavily armored Stegosaurus. Evidence of bite marks on fossilized bones shows it attacked large sauropods, perhaps targeting the young or the weak. But Allosaurus was not alone in this dangerous ecosystem. Other predators, including smaller theropods, competed for food. Whether Allosaurus hunted in packs or alone remains an open question, but fossil evidence of multiple individuals found together has led some scientists to speculate on cooperative behavior. The Morrison Formation of North America has yielded an abundance of Allosaurus fossils, making it one of the best-known predators of the Jurassic. Yet, mysteries remain. Why did so many individuals end up preserved together in sites like the Cleveland Lloyd Quarry? Was it the result of droughts, predator traps, or social behavior gone awry? The answers remain debated, with each new discovery adding pieces but never the full picture. When Allosaurus vanished at the end of the Jurassic, it left behind a legacy as one of the great hunters of prehistory. Its bones speak of power, agility, and adaptation, but also of questions left unresolved. And as we compare it to the predators that came after, one question lingers. Was Allosaurus the blueprint for the giants yet to come, or a unique chapter in the story of life's most fearsome hunters? Diplodocus in the lush floodplains of the late Jurassic, one of the longest creatures ever to walk the Earth, moved slowly across the landscape. This was Diplodocus, a sauropod whose extraordinary length and whip-like tail made it unlike any other giant of its age. Stretching up to 90 feet from head to tail, it remains one of the most iconic dinosaurs discovered. Yet its life and behavior are still wrapped in questions that continue to puzzle paleontologists. Diplodocus lived around 150 million years ago in what is now North America, with fossils most famously recovered from the Morrison Formation. Its body plan was instantly recognizable. A small head perched at the end of a remarkably long neck, a massive barrel-like body supported by 4 sturdy legs, and a tail that could extend nearly half its total length. This tail, slender and flexible, may have functioned like a whip, either as a defensive weapon against predators such as Allosaurus or as a tool for communication within herds. Its diet shaped both its anatomy and its world. Diplodocus was a herbivore, feeding on ferns, cycads, and conifers that blanketed Jurassic floodplains. The structure of its teeth, peg-like and positioned at the front of the mouth, suggests it stripped vegetation rather than chewing it. Instead, food was swallowed in large amounts and processed in a vast digestive system, possibly aided by stones swallowed to grind plant matter. The long neck allowed it to reach vegetation at different heights, reducing competition with other sauropods. But how exactly did Diplodocus hold and use its neck? Some reconstructions show it stretching high into the treetops, while other studies suggest it was held more horizontally, sweeping across broad areas of low-lying plants. This uncertainty highlights one of the many mysteries surrounding its lifestyle. The discovery of multiple Diplodocus fossils in close proximity raises questions about social behavior. Did these giants move in herds, offering protection and structure, or were they more solitary, converging only in certain environments? Trackways hint at group movement, but the evidence is not definitive. Diplodocus also challenges our understanding of biomechanics. How did such a massive creature support its weight and move with any degree of efficiency? Studies of its limb structure suggest it walked with a steady, column-like gait, covering vast distances in search of food and water. Yet its sheer size makes even the act of breathing and circulating blood a topic of ongoing research. Today, Diplodocus is one of the most widely recognized dinosaurs, with casts of its skeleton displayed in museums worldwide. Still, behind the familiar silhouette lies a creature whose life remains only partly understood. A giant whose true story, like its endless tale, stretches far beyond our reach. Apatosaurus in the ancient river valleys of the late Jurassic, one of the most colossal plant eaters to ever roam the earth, left its mark in stone. This was Apatosaurus, a sauropod dinosaur whose immense frame and long, sweeping tail made it a true giant of its time. Though its bones are among the most studied, the details of its daily life remain full of intrigue and debate. Apatosaurus lived about 150 million years ago in what is now North America. Measuring up to 75 feet in length and weighing as much as 30 tons, it was a creature built on an enormous scale. Its neck, stretching nearly 30 feet, allowed it to feed across wide swaths of vegetation, while its muscular tail may have served as both a counterbalance and a defensive tool. Unlike predators that dominated through speed and aggression, Apatosaurus commanded the Jurassic landscape through sheer size and endurance. Its name, meaning deceptive lizard, reflects a long history of confusion in paleontology. For decades, Apatosaurus was mistakenly linked with the famous Brontosaurus, a mix-up that persisted in textbooks and museums well into the 20th century. Only through careful study were scientists able to separate the two, restoring Apatosaurus to its rightful place in the dinosaur family tree. Yet the shadow of that confusion continues to linger, adding a layer of mystery to its story. The anatomy of Apatosaurus suggests it was a ground-level to mid-level browser, sweeping its long neck from side to side to feed on ferns, cycads, and conifers. Its peg-like teeth were not suited for chewing, meaning it likely swallowed vegetation whole, relying on its massive gut to break down food. Some paleontologists believe it may have swallowed stones, gastroliths, to help grind plant matter internally. But one of the greatest questions lies in its tail. Stretching longer than the rest of its body, it tapered into a fine tip. Some researchers propose that it could be cracked like a whip, producing a sound as loud as a gunshot, either for defense or communication. Others argue it was mainly a balancing tool, stabilizing its immense body as it moved. The true function remains an open debate, locked within the fossil record. Despite its size, Apatosaurus may not have lived alone. Trackways suggest sauropods sometimes traveled in groups, perhaps for protection or to exploit resources together. But whether Apatosaurus formed herds or wandered more independently is still unknown. Today, the fossils of Apatosaurus stand in museum halls as reminders of Earth's long-lost giants. And as paleontologists continue to uncover new evidence, one question endures. Was this giant simply a quiet browser of Jurassic forests? Or did its world hold secrets about its behavior that we have yet to uncover? Camarasaurus in the Jurassic landscapes of North America, among forests of conifers and towering ferns, lived one of the most common and successful sauropods of its age, Camarasaurus. Though not as massive as Diplodocus or Brachiosaurus, this long-necked giant thrived where others struggled, leaving behind a wealth of fossils that make it one of the best-known sauropods today. Yet, even with this abundance of remains, its life story is still layered with mystery. Camarasaurus, meaning chambered lizard, lived around 155 to 145 million years ago. Adults grew between 50 and 65 feet long and weighed up to 20 tons, placing it among the mid-sized sauropods. Its name refers to the hollow chambers in its vertebrae, an adaptation that made its immense skeleton lighter while still strong enough to support its bulk. These air-filled bones also hint at a respiratory system more like that of birds than modern reptiles, suggesting a level of efficiency vital for sustaining such a massive creature. Its skull was distinctive, shorter and more box-shaped than those of its sauropod relatives, with large, spoon-shaped teeth well-suited for grinding tougher vegetation. This dentition reveals that Camarasaurus may have fed on coarser plants, giving it access to food sources less favored by other sauropods. This dietary flexibility likely contributed to its abundance, allowing it to coexist with giants like Diplodocus and Apatosaurus without directly competing for the same resources. Fossil evidence suggests Camarasaurus was widely distributed across the Morrison Formation, from what is now New Mexico to Wyoming. Many complete skeletons have been unearthed, including juveniles, indicating that it may have lived and traveled in family groups. Tracks attributed to sauropods support the idea of herd behavior, offering protection for the young and efficiency in foraging. But whether Camarasaurus truly lived in organized herds or in looser associations remains a question still debated. Its role within the Jurassic ecosystem was significant. By feeding on resilient vegetation and moving in large numbers, Camarasaurus likely helped shape its environment, clearing forests and dispersing seeds. Its sheer size meant that few predators dared challenge a healthy adult, though fossils of juveniles show evidence of attacks by Allosaurus and Ceratosaurus. Despite the wealth of material, mysteries endure. How fast did Camarasaurus grow, and how long did it live? Were the chambers in its bones purely for weight reduction, or did they serve other biological functions tied to respiration and temperature regulation? Each new fossil discovery adds clarity, but also raises new questions. Camarasaurus may not be as famous as some of its towering relatives, but its success tells us much about survival in the Jurassic world. And as its fossils continue to speak across millions of years, they remind us that even the most common giants still hold secrets waiting to be uncovered. Ankylosaurus in the fading days of the Cretaceous, when towering predators like Tyrannosaurus rex prowled the land, another kind of giant moved silently across the plains. This was Ankylosaurus, a living fortress whose body was clad in heavy armor and crowned with a tail that could deliver bone-crushing blows. Often called the armored tank of the dinosaur world, Ankylosaurus was built for defense, yet its life remains filled with unanswered questions that keep its story shrouded in mystery. Ankylosaurus lived about 68 to 66 million years ago in what is now North America. Reaching up to 26 feet in length and weighing nearly 8 tons, it was one of the largest and last of its kind. Its most striking feature was the armor. Bony plates known as osteoderms embedded in its skin, forming a mosaic of protection across its back and sides. Some plates were flat and shield-like, while others rose into spikes, making it a formidable obstacle for any predator that dared to attack. The tail club, however, was Ankylosaurus' defining weapon. Formed by fused vertebrae and covered in heavy bone, it could swing with devastating force. Studies suggest the tail could deliver impacts strong enough to break the bones of a predator, even crippling a Tyrannosaurus in a well-aimed strike. Whether it was primarily used in combat with predators or in displays against rivals remains uncertain, but its presence made Ankylosaurus a creature few would challenge lightly. Despite its heavy armor, Ankylosaurus was not a creature of brute force alone. Its wide, low-slung body and short, powerful limbs suggest it grazed close to the ground. With a beak at the front of its jaws and small, leaf-shaped teeth, it fed on ferns, cycads, and low-lying shrubs. Its digestive system may have been specialized to process tough vegetation, allowing it to thrive in environments that supported fewer resources. And yet, mysteries surround its behavior. Was Ankylosaurus a solitary grazer, hidden in the low vegetation, or did it live in groups where many armored bodies offered protection in numbers? Did its club tail play a daily role in survival, or was it a weapon used only rarely? The fossil record hints at possibilities, but leaves no clear answers. When the asteroid struck at the end of the Cretaceous, Ankylosaurus vanished along with the giants of its age. Today, its fossilized armor and broken fragments of bone remind us of a creature that was both shield and sword, a defensive masterpiece of evolution. And as we study its remains, the question lingers. What other secrets lie hidden within the stone, waiting to tell the full story of the armored guardian of the Cretaceous?